This video will introduce the last of the 6 steps of a 6-step programming process. It is with function creation. The step 5 part of the 6-step programming process is where the supporting functions are designed, and step 6 is where the supporting functions are implemented, or we say that we write the code for them. So at this point right here, we'll go to the code. One more time, we'll take a look. Step 1 in our main function was our main steps. Step 2 was our substeps. Step 3 was where we put in the identified and located, and then later specified our functions, what they would be like. Step 4 was actually implementing or writing the code for the main function. Step 5 took that process and turned it back around again. So in step 5, where we had empty stub functions here, we started back over with steps 1, 2, and 3 in each function. So we have initialize, which we have at the beginning of pretty much all supporting functions. Our main step here, print title complete, and then substeps, these are step 2 quantities. Print the title with the end line, the underline with the end line, and the extra end line for vertical space are your step 2. And then your step 3 is placed in there to talk about what kind of tools you're going to be using. So when you get down to this step 6 is much like your step 4 in the sense that all you're really going to do is load up. You're going to put the code in here where you're told to put it, where your instructions have indicated that. So let's go ahead and take a look at that. The first thing we need to do, we're still in quad step 5, so we will save this as quad step 6, and we will go ahead and print our title. We really don't even have to go back up to the specifications anymore, because all we really need to do is follow our instructions. So this instruction right here says to print the title with the end line. So we will type a C out, and we'll put this in capital letters, quadratic root calculator. And then we say we're doing this with an end line, so we'll do that. And we'll compile. Compiler's happy. We'll take that and copy it right down here. And then what we'll do is punch that insert key and make the underline so we don't have to try to type anything over again. And unpunch the insert key, compile, happy compiler. And then finally we're going to add one more end line space here just so we'll have a vertical space between the title and where we start doing the prompting for the coefficients. So we'll simply do a cout endl here, and then we'll do a compile. I think you can see that as easy it was to design this, it's even easier to just write the code because you're just doing what you told yourself you're going to do. Now, on this one, it's going to be prompting for the coefficient. So you're going to prompt the user for the coefficient, and you're going to use the letter. So what you will have here is a cout, enter coefficient, we'll leave a space, and then we'll put that prompt letter there. And then we have to put, let's go to the next line here. And we'll put a colon and a space. All right, now what will happen here is we'll enter the coefficient. We'll be given the letter that was given to us when this function was called, A or B or C. That will be placed there. And then a colon and a space, and that's what it's going to take for the user to be prompted for that. We'll compile this. Compiler's happy with this. And so now all we have to do is take it in. So we're going to have to take cin user input. Well, obviously if we're going to do that, we have to create that variable. So we will come up here and we will put that variable there, user input. And what's important here is to don't forget to remove this temporary stub return here and then put the user input right there. Okay, this is a couple of lines of code, so we'll compile, and we have a happy compiler. Quick review on that. We're going to enter the coefficient, the letter that the user is asking for, A, B, or C, and then a colon right after that so that there'll be a prompt for the user to where to put their value. They'll enter the value, and we'll take that in with our input process, and then we will return that back to the calling function, which is the main function. That function, as you recall, is called 3 times up here. Prompt for coefficient with the letter A, and assign to coefficient A. Prompt for coefficient with letter B, assigned to B, and with letter C, and so on. So we go on to calculating the discriminant. This again is going to require a variable. We'll go ahead and we'll just say disk is assigned, and the discriminant, we have to go back and we have to look at what our calculation looks like here. That was the b squared minus 4ac. So we can do that. We can say coif b times coif b. Again, C++ does not have a power operation in the language. You could use pow, but for one as simple as this, you will actually maintain better accuracy and better precision if you just multiply them together. And then we take the 4 times the coefficient a times the coefficient c, and we better compile there, except we have a disk variable here. So let's go ahead and set that in there, int disk, compile that. And it says disk set but not used. We can solve that one because again we'll take out our temporary stub return, replace it with disk, and compile. And everybody's happy there. Pretty much the same thing is going to happen here. We're going to take int denom. We're going to assign denom to the denominator quantity. If we go back and look at that, that is very simply 2 times the coefficient of a. So 2 times coef a. We get coef a from the input from right here. So we're bringing that in there with a semicolon. And then we will again take out our temporary stub return, put in denom. We will compile. Happy compiler. Now the calc root, if we go back and look at what that looks like, now we've modularized things. We've got a quantity that's coefficient b, or minus coefficient b actually. We've got a quantity that is the discriminant square root, and we've got a quantity that is the denominator. So we just have 3 quantities we need to work with here. We are certainly going to get an answer out of this, so we'll call this the root. It will be double because one of our values, the disk square root, is double. Okay. Root is going to be assigned to, have to put parentheses around this for the division, the opposite of coefficient b plus the disk square root, and that'll all be divided by the denominator. I'm going to do a quick compile. It'll tell us it's root set but not used, and we can live with that. We'll put root right here, compile it, and we have completed the process here. So now we've got the calculation of the discriminant. We brought in 3 values, coefficient a, b, and c. We used them for our calculations, and we sent back the solution, the result of that calculation. Here we brought in 1 value. We had to use it for our calculation, and we sent back the denominator from that. In the case of the root, we brought in the coefficient of b, the disk square root, and the denominator, and we took the numerator part here, the opposite of coefficient b, plus the disk square root, and we divided that by the denominator. Now remember that when this is called, the first time it's called, it will be called with a positive discriminant square root. The second time it will be called with a negative discriminant square root, and that simply will be added in right here as a negative quantity. When this was all done, we take this data, we process it here, and we send back our solution there. Now display root, again, is going to be very simple. We're going to come in here. We did have to create a couple of variables on these, but for displaying the roots themselves, we will not have to do that. So we're going to display the root number, and that is simply going to be root number root num. And we'll stick up a colon and a space for that. And then we will say cout the actual root value. And then we will end the line. We could have compacted this all really into just one line, but it was an opportunity to talk about how the step 1 and step 2 in the functions go for this fairly simple program. Check our compiler. Compiler seems to be happy with this, and so there's really only one thing left to do. We are finishing up the end of step 6 here. Well, all we did was we came into each one of these and we just followed the instructions we were given at each line. That's all we did. We didn't even go back and look at specifications. We certainly did go back. We looked at our calculation here just for reference, but that was the best we had to do there. We simply had to come in and try things out. So we stuck into here, follow this instruction here, and so on. So there's really only one thing left to do. We have compiled it. The compiler is happy. And all we need to do now is run the program. So we will punch our little run button, bring it into the screen here. We will give it a 1, a -1, and a -6 known quantities. We will see that our root number 1 is 3, our root number 2 is -2, and we're ready to go. This program worked the very first time we ran it. You might want to make spaces above root number and below root number. You might want to break this up a little bit, but that was not part of this lesson here. The lesson was really focused on creating functions, and doing some of the other tweaking can be done in other functions. You could break that down even more if you wanted to, but it was a little outside the scope here. Bottom line here, however, is that in fact, the first time you ran the program here, it worked. That's not always guaranteed. However, it will work like that most of the time. And on those occasions when it doesn't, those will be the times that, in fact, by using your modularity, by using the development of this, you will be able to identify where the problem goes wrong, whether it got bad input, whether it did some internal calculations incorrectly, or whether the calculation, the root of itself was bad, or whatever. You will know that because you've developed this in a modular way. So let's go ahead and wrap this up. And this is going to be the end of the 6th step of the 6-step programming process. The function creation process here started in step 3, where they were located, the functions were located and identified, and then they were designed, because these were functions being created by the programmer. And then finally in that was step 3. Step 4, the main function was written. Step 5, the designs for the supporting functions were written. And in step 6, the code was actually what we say implemented, or the code was written for the supporting functions, and then the program was tested and run. So as you can see, as long as you're systematic and consistent with developing programs like this, you really can have programs done in fairly short periods of time, and they will be very good quality programs. That will be the end of this video.